Okay, good morning. Welcome to
FamilyMath number 828.
FamilyMath 828. So, you are studying a little bit of statistics right now in your book. So this is going to be material that's new for you. But one of the things that came up in your chapter that you're on right now is something called the law of large numbers and the central limit theorem. And very informally, the law of large numbers. Actually, do you know what that says? No? Okay, so you're just getting into this. The law of large numbers says that when you do an experiment a repeated number of times and sort of add up the outcomes and take the average of that, and it kind of looks like the average of the distribution. So the law of large numbers says if you do a large number of experiments, you should expect that your average result is the average.
All right.
Of the distribution, right?
All right.
And then in your book it says the difference starts looking like a bell curve. And I'm going to show you one case today where that's true, and I'm going to show you one case today where it's not true.
All right.
Okay. So just to help you understand that a little bit better. So one of the exercises in your book said somebody shoots free throws. Oops, sorry about that. Put the page down instead of scroll down. Somebody has a 0.642 chance of making a free throw, and they take 164 free throws. So if you were going to if you had a 64.2% chance of making a single free throw and you took 164 of them, how do you think you would figure out how many you would make on average?
Well, maybe you could multiply these two numbers together.
Okay, so
164 times 0.642.
Okay, so 164 times 0.642. I have a little calculator handy. 100. There it is. Sorry, maybe not so handy. 164 times 0.0642, and that is 105. Yeah, 105.288 actually.
Alright.
Okay, so I wrote a little Mathematica program, and we're going to do this 1,000 times.
Alright.
We're going to do an experiment where we do 164 tries at a 64.2% chance of success every try, and we're going to see what we get. And let me scroll down to get this on screen. Here's what we get. Here's a histogram of what we got.
Alright.
Okay, so what do you think about that?
So this kind of looks like the normal distribution.
Alright, what makes you say that?
Well, we've got low numbers out here, like less than 90 or more than 120. And we get higher numbers sort of close to 105, which is what our average was.
Okay. And I'm going to take the same data down here, and I'm going to plot it against an actual normal distribution. Probably zoomed in a little bit too far here.
Yeah.
So let me just shrink this up. Sorry, we're going to have to do some adjustments to this thing on the fly here. Maybe that'll be good for us. Alright, is that on screen now?
This end is not. That's better.
Okay, sorry about that. So here we see our 1,000 samples against a normal distribution, which is the red line, or the red curve, and against something else called a binomial distribution, which is the blue curve. And you can see that they're very close together. In fact, they're so close together I did the binomial as points so that you can see them separately.
Alright.
Okay. So what do you think? Is that a good fit to that distribution?
Pretty good, yeah.
Alright, what do you think?
The two top ones are a little bit too big, and then, it's all in all, it's pretty good.
Okay. Well, now I'm going to go back up to the top, and instead I'm going to do 100,000 trials. Okay. And that takes a little bit of time to do because the trials are a little bit complicated, but hopefully it'll show itself shortly. What do you think this one's going to look like?
Well, it might look about the same.
I think it'll look more like.
Yeah, I think you might have more.
It'll look more like the normal distribution.
All right. Well, there's what it looks like. And then down here, I'll plot it against the normal distribution and the binomial distribution.
It looks a lot better.
What do you think now?
Well, this actually looks like almost exactly perfect.
Okay.
Against the normal distribution.
I guess here, because even if you have like an extra like 50 in a column, it doesn't matter as much because you're doing so many more trials.
Okay.
I mean, like in the middle columns, if you had an extra 50 out here, it would matter.
Yeah. But you start seeing what both the law of large numbers and the central limit theorem are talking about. That in the distribution of outcomes of 164 trials, shooting free throws, with a 64%, you start getting a shape that looks like a bell curve. Is this surprising to you?
Well, not really. I mean, you should sort of expect, like, after you do a lot of trials, you should expect some patterns to occur.
Okay, yeah, that's a good intuition. Why do you think there should be some patterns?
Well, because, like you said, there's an average number of things you should expect, and a lot more times you'll get around that, and then, like, as you go farther and farther away, there's less times you'll actually get that.
Okay.
So, yeah.
All right, so up here you can see that our distribution has a mean of 105. 0.28, which is basically what we were looking for, and a standard deviation of 6.16, which is a measure of kind of how wide the distribution is.
All right.
Okay, so we start getting a bell curve. Now I'm going to show you an example of one where this doesn't work so nicely.
All right.
Okay.